Here in this video, we would like to find out the unit of coefficient of thermal conductivity. So first of all, we shall understand what is that thermal conductivity is, right? So let us consider a solid material who is filled with solid content and heat has to pass through this solid material. Let the length of this conductor is L, area of cross section is A, temperature at this point is theta 1, temperature at this point is theta 2. Heat has to flow through this dq. So according to thermal conductivity nature, the amount of the heat flows is directly proportional to area, directly proportional to the time for which the heat flows, directly proportional to temperature difference, and is inversely proportional to the length of the conductor. So if you eliminate the proportionality, you can put a constant called coefficient of thermal conductivity, Ka delta theta dt by L. So where that K is called coefficient of thermal conductivity, our intention is to find out the units and dimensions of that coefficient of thermal conductivity. Where dq is the heat energy, let's write the units and dimensions of each of that. Heat energy, energy can be measured with a unit called joule. K is coefficient of thermal conductivity, we have to find its unit. A is the area of cross section of the conductor. In SI system, area is measured with meter square. Delta theta is the temperature difference. We can measure that in Kelvin or degree centigrade, but as we are writing SI system, I have written Kelvin. Be careful, this K for Kelvin, this K is coefficient of thermal conductivity, that is different. dt is the time for which the heat flows. The time is having a unit of second, by length has a unit of meter. So 1 meter and 1 meter in the numerator gets cancels. So what is remaining is joule equal to K, coefficient of thermal conductivity, meter, Kelvin, second. Let's keep the K only on that side and get everything else to the other side. So K becomes joule by meter, Kelvin, and second. Joule is energy, second is time. Energy per time is called as power. Power has a unit called watt. So joule per second is having another name called watt. So the unit is watt meter Kelvin, or the unit is watt meter inverse and Kelvin inverse. If you look at the units, that means the option is given for you. C is the right option for you, watt, meter inverse and Kelvin inverse. Anyway, if you are interested in writing a dimensional formula, you can write that also. That's not at all difficult. Just a second. Yeah. Dimensional formula, if you want to write for K, yeah. Energy has a dimensions of ml square t power minus 2. Meter is the length, so L is the dimension. Temperature is the Kelvin, you can write it like theta by second. Second means time, so it is measured with T. So the dimensions of that is 1L gets cancels, M, L power 1, T power minus 2, and this plus 1 and the numerator becomes minus 1, that is minus 3, and theta inverse or Kelvin inverse. That's a dimensional formula of coefficient of thermal conductivity. So coefficient of thermal conductivity, what it is? It's actually a measure of ability of a conductor to pass heat through it. Heat through it. Higher the value of the K, it's more comfortable in passing the heat through it, is the meaning of that. That's how we can find out coefficient of thermal conductivity. That is a question given in NEET 2019. That's for your information. Thank you for watching.